completely wrong with what I thought 14.2 was going to be. I thought we were going to be looking at trig stuff. Not yet. We're going to do a little bit of geometry again today. So a nice little geometry review in this chapter. We're going to look today at different geometric properties and then some properties of triangles. So we're going to look at parallel lines. We're going to look at a bunch of different geometric properties to kind of review those concepts as well as review the concepts of triangles today. So again, some terminology to make sure you have down and you get back into your mind. Remember, vertical angles have equal measures to each other. So when we're talking about vertical angles, we're talking about angles that are kind of across from each other when you have two lines that intersect. I kind of say it's the top and the bottom of the x or the sides of those x's. And those two pieces are going to be congruent to each other. So these two angles right here are vertical angles, and those vertical angles are going to be congruent. So if I tell you that that one's 10, that one has to be 10. If I tell you that this one is 170 degrees, this has to be 170 degrees. It's kind of those across or on top of each other angles when you've got two intersecting lines. And vertical angles are always going to have equal measures, so you're always going to be able to set vertical angles equal to each other. Okay, so that's first property. Parallel lines. Remember, parallel lines are lines that on the same plane that do not intersect. So in this case, these two blue lines are parallel lines. Parallel lines are intersected by what we call a transversal. That's the red line. That's the transversal. Now you'll notice that the transversal breaks the parallel lines into different coordinates or different quadrants. So we've got like angle 1, angle 2, 3, 4, 5, 6, 7, and 8. And we just talked about vertical angles. So like angle 2 and angle 3, those are vertical angles. 1 and 4 are vertical angles. 5 and 8 are vertical angles. And 7 and 6 are vertical angles. They're kind of across from each other. So those angles, since those lines are parallel, even if they weren't, vertical angles are going to be congruent to each other, so they are going to have the same measure. But a transversal is any line that intersects two or more lines. They don't necessarily have to be parallel. Certain properties hold if they're parallel, and that's probably where we're going next. But yeah, so alternate, so some things to keep in mind. Again, back to the geometry scope a little bit and trying to get you to remember some geometry. But when we have this, these two parallel lines being cut by a transversal, we have different types of angles that are formed. We have what are called alternate interior angles. Okay. Alternate interior angles. So alternate interior angles means that they're both inside of the parallel lines on opposite sides of the transversal and not adjacent. So angle 4 and angle 5 are alternate interior angles. They're both on the inside, opposite side of the transversal, and non-adjacent. Same thing with 3 and 6. Those are what we call alternate interior angles. The second type is alternate exterior angles. Exterior means on the outside, alternate means on the opposite side of the transversal, and they're non-adjacent. So angle 1 and angle 8 are alternate exterior angles, as are angle 2 and angle 7. Now, in the two cases of alternate interior and alternate exterior angles, if the two lines that the transversal are intersecting are parallel to each other, then alternate interior angles and alternate exterior angles are going to have the same measure. Okay. Interior angles or same side interior angles mean that they're on the inside and on the same side of the transversal. So same side interior angles would be 4 and 6 or 5 and 3. Those are alternate same side interior angles. On the same side, on the inside. My son's car didn't start this morning and probably ran out of gas, so he just emailed me that, yep, he ran out of gas. Good job, buddy. Anyway, so with same side interior angles, their measures add up to 180 degrees. So angle 4 plus angle 6 has to add up to 180 degrees. 3 plus 5 has to add up to 180 degrees. The last type that they talk about in here are corresponding angles. With corresponding angles, one angle's on the inside, one angle's on the outside. They're on the same side of the transversal and non-adjacent. So 2 and 6 are corresponding angles. 1 and 5 are corresponding angles. 3 and 7 are corresponding angles, and 8 and 4 are corresponding angles. And just like alternate interior and alternate exterior angles, if M and N are parallel to each other, then those are congruent to each other. Okay, so those are some properties that you need to make sure you kind of remember. So let's find angle measures. So it says find the measure of angles 1, 2, 3, and 4 given that M and N are parallel. So the first thing I identify is I kind of look at it and say, okay, I've got two angles here and here. Those two angles are both on the outside, on opposite sides of the transversal and non-adjacent. So those are alternate exterior angles. And alternate exterior angles, by our last slide, are congruent to each other. That means that they equal each other. So 3x plus 2 has to equal 5x minus 40. Now we solve. Move the 3x over here. So I'm going to subtract 3x from both sides, so that gives me 2x. I'm going to add 40, so that's 42. Solve, that gives me 21. So x is equal to 21. It doesn't give me the measure of the angles, but it tells me what x is equal to. So I can substitute that in there. If I substitute it in there, 3 times 21, 3 times 21 plus 2, 3 times 21 is 63. 63 plus 2 is 65. So the measure of this angle right here is going to be 65 degrees. So now it's asking me to find the rest of them. So I know angle 1 is 65 degrees. That means angle 4 has to be 65 degrees because alternate exterior angles are congruent. It also means that angle 1 is 65 degrees because 1 and 3 are vertical angles, and vertical angles are congruent. So all we have left to find is angle 2. Well, if you look at angle 2 and angle 3, they form a straight line. We talked about that in the last lesson. If they form a straight line, they have to add up to 180 degrees. So if I go 180 minus 65, which is 115, that's going to give me the measure of angle 2. And we've answered all of their questions. Okay? Here's their explanation, same explanation I used. They got 65, just like I got. They use substitution, they use supplementary angles, they get 115 degrees. Okay? So that's angles and triangles, and we're going to do another one here down at the end. We're going to do a couple more examples of those here in just a little bit. But now let's take a look at triangles. Specifically the angle sum theorem. The interior angles of a triangle is 180 degrees. So any triangle you have, if you've got a triangle, those interior angles, x plus y plus z, have to add up to 180 degrees. And this was probably one of the most things that was ingrained in your head in geometry. And so you've seen this thousands of times. The sum of the interior angles of any triangle is going to be 180 degrees. So if they give us the two measures and we want to find the third, just have to add them all together and set it equal to 180 degrees. So x plus 48 plus 61 has to be 180 degrees. 48 plus 61 is 109. So x plus 109 equals 180. Subtract, you get x is equal to 71 degrees. There you go. That's the measure of the third side. 3 sides have to add up to 180 degrees. Exactly what we get. Okay. Again, different types of triangles. In an acute triangle, all the angles are less than 90 degrees. In a right triangle, which we're going to work on quite a bit with the rest of this chapter, I think. In a right triangle, you have one right angle. And in an obtuse triangle, you have one angle that's greater than 90 degrees. The rest are acute angles. So all acute angles right, one right angle, and obtuse, one obtuse angle. Again, just reminding you of those different types of things. We can also name triangles by their sides. If all the sides are equal, we call it equilateral. If two sides are equal, we call it isosceles. If no sides are equal, we call it scalene. Equilateral, all. Isosceles, two. Scalene, none. Terminology. Cut by a transversal. So two parallel lines cut by a transversal. If I tell you that this is 5x plus 80, and this side is x, measure that angle's x, I can actually ask you to find the rest of them. We're going to find the measures of all the angles. 1, 2, 3, 4, 5, 6. And we'll find the other ones too. Okay. So these are same side interior angles. And same side interior angles add up to 180 degrees. So 5x plus 80. Ooh. Does this work? Ooh. 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 We're going to change this to 4x plus 80. Let's change this to 4x plus 8, just because I want the numbers to work out nice. Sorry, didn't think about it till I got to that point. So let's go 4x plus 80. Sorry about that. So we've got 4x plus 80 plus x is going to be 180. So 5x equals 100. X is equal to 20. So if x is equal to 20, that makes this angle right here, it's changed to blue, that makes the measure of this angle here 20 degrees. So 5 is a vertical angle, so that has to be 20 degrees. 3 is an alternate interior angle, so that has to be 20 degrees. And 2 is a corresponding, but also vertical to 3, so that has to be 20 degrees. If we substitute the back up into the x, that's 80 plus 80 is 160. So then the rest of them are going to be 160 degrees. Okay. So there's just one more example of things you're going to look at today. A lot of terminology in this lesson today. A lot of things to remember from the geometry piece of it. Just kind of keep all those different types of things in mind when you're going through your lesson today, and remember that the sum of the interior angles of a triangle is 180 degrees. See you next time.